Hello everyone, welcome back to my YouTube channel. This is Sangeeta Bijay from Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering, second sem each section. Today in this video, we are going to discuss about the subject Introduction to Civil Engineering, and our topic is sound control and temperature control in buildings. Introduction to building controls. Building controls are essential for maintaining comfortable and energy efficient indoor environments. They encompass a range of systems and technologies that regulate various aspects of a building, including sound, temperature, lighting, and ventilation. Importance of sound control in buildings. Improved productivity. Excessive noise can distract employees, hindering focus and reducing productivity. Sound control creates a peaceful work environment, fostering concentration and efficiency. Enhanced learning environments. Quiet classrooms are essential for optimal learning. Sound control minimizes distractions, allowing students to concentrate on their studies and teachers to deliver effective lessons. Enhanced health and well being. Noise can disrupt sleep and increases stress levels. Sound control in hospitals creates a peaceful and restful atmosphere, promoting patient recovery and well being. Improved acoustic experiences. Proper sound control ensures that music performances and presentations are heard clearly and without distortion. It enhances the overall enjoyment of these experiences. Techniques for sound insulation and absorption. Sound insulation. Sound insulation prevents sound from traveling between rooms or spaces. It involves adding materials to walls, floors, and ceilings that block sound waves. Dense materials like concrete and drywall effectively reduce sound transmission. Adding layers of insulation such as fiberglass or mineral wool further enhances sound insulation. Sound absorption. Sound absorption reduces sound reflections and echoes within a room. It involves using materials that absorb sound energy rather than reflecting it back. Porous materials like acoustic panels, carpets, and curtains effectively absorb sound. These materials trap sound waves and convert them into heat energy, reducing reverberation and noise levels. HVAC systems and their impact on sound. Air handling units. Air handling units contain fans and motors that can generate significant noise, especially at high speeds. Ductwork design. Properly designed ductwork minimizes noise transmission by using sound dampening materials and avoiding sharp bends. Air filtration systems. Air filters, while essential for air quality, can contribute to noise levels if not selected and installed appropriately. System control and operation. Optimizing system settings and maintaining equipment can reduce noise levels and prevent unnecessary operation. Factors affecting indoor temperature regulation. External climate. Outdoor temperature, humidity, and solar radiation directly influence indoor temperature. Hot climates require more cooling, while cold climates need more heating. Occupancy and activities. The number of occupants, their activities, and equipment usage generate heat. Human bodies, lights, and appliances can significantly impact indoor temperature. Building envelope. The building envelope, including walls, roof, and windows, determines heat transfer between the interior and exterior. Insulation and window glazing play a crucial role. Ventilation and air infiltration. Air movement through windows, doors, and leaks can introduce warm or cold air, affecting the overall temperature balance. Ventilation systems also contribute to temperature regulation. Passive and active temperature control methods. Passive methods. Passive techniques utilize building design features to regulate temperature without mechanical systems. These include proper insulation, shading, and natural ventilation. Active methods. Active methods involve mechanical systems to control temperature. These include heating, ventilation, and air conditioning systems, which use energy to regulate indoor climates. Hybrid approach. Combining passive and active strategies creates an energy efficient and comfortable environment. Integrating natural ventilation with HVAC systems optimizes temperature control while reducing energy consumption. Thermal comfort and energy efficiency. Optimizing indoor climates. Thermal comfort refers to the satisfaction with the surrounding temperature, humidity, and air movement. It is essential for productivity, health, and well being. Reducing energy consumption. Energy efficient building systems and technologies minimize energy usage while maintaining thermal comfort. This reduces operational costs and environmental impact. Sustainable building practices. Sustainable design principles prioritize energy efficiency and minimize environmental footprint. Implementing the practices promotes long term cost saving and reduced carbon emission. Integrating sound and temperature control systems. Integrating sound and temperature control systems creates a more efficient and comfortable environment. Coordinating these systems reduces energy consumption and improves overall building performance. Building automation systems can integrate these controls to create a unified platform. This allows for centralized management and monitoring of both sound and temperature levels throughout a building. Building automation and intelligent controls. Centralized control. Building automation systems provide centralized control for managing various building systems, including sound and temperature, data analysis, and optimization. Intelligent controls use data analytics to optimize building performance, reducing energy consumption and improving comfort. Remote monitoring and management. BAS allows for remote monitoring and management of building systems, enabling proactive maintenance and troubleshooting. Adaptive control. Intelligent controls can adapt to changing conditions such as occupancy levels and weather patterns to optimize building operation. Conclusion and takeaways. Sound and temperature control are vital for creating comfortable and productive environments. Integrating these systems improves building performance and energy efficiency. Intelligent controls offer centralized management and data driven optimization. Thank you for watching. Please do like, share, and subscribe to my YouTube channel.